Tuesday, which means it's time for math. My name is Jeremy Jasper with KathleenJasper.com. And just like we do every Tuesday from 5 to 6 p.m., I'm here to show you all things math for your teacher certification exams. So welcome to everybody who's joining me live. As usual, it's great to have you. I'm so glad that we can bring this to you. And to those of you watching on the recording, I'm glad you're able to find us, and I'm glad that whatever I am able to do to help you pass your teacher certification exam or whatever standardized math test you're taking, I am able to provide that for you. So just like every session for the next hour, I'm going to go over 10 problems that I've pulled or you've sent in that kind of encompass a little bit of everything. You know, I'm not going to hit everything all the time, but throughout these sessions and throughout these months, and I think going on a year and a half or a couple of years at least, we've done a little bit of everything so that I can give you a general understanding of what to expect when you take these tests and how to get through them efficiently, effectively, and in a timely manner. So I'll go ahead and give everybody a quick minute to just go ahead and sign in, sign up, get everything ready. You're able to access the problems that you'll be seeing tonight, either on our YouTube channel or on, on our YouTube channel or on our Facebook page. And those are done in PDF form. And so you'll be able to go ahead and get those at your own leisure and then work on them as possible. All right, let me just go ahead and make sure if you have any comments while we're going through this, please go ahead and put them in the comments section below. I will try to get to them as much as I can during the session and make sure that I answer everything. In the event that I'm unable to get to you live, then please bear with me so that I can, I'll go ahead, send me an email, info@KathleenJasper.com, and we'll be more than happy to answer any questions that you might have. So let's just make sure everything's on the up and up, and then I will go ahead and make sure we get everything going here. And it looks like everything is good. Okay, let's go ahead and get started. All right, first thing I wanted to cover, and it has to do with our website. So KathleenJasper.com was formerly NavaEd.com. We went ahead and went through a brand change. And so we still offer all the great resources, and specifically focusing on Praxis and getting into many other states that have different certification exams. And so, you know what, let's go ahead and do this because I gotta share the screen or else you can't see it. Okay, so here we go. Our website, KathleenJasper.com, we offer many programs dealing with many different certifications, and it's very user-friendly. And, you know, we're always available to you to provide whatever help that you'll need for whatever test you're taking. On the programs you'll see that are offered, these are the programs that we offer. And then just specifically only because I'm dealing with math on these Tuesdays, if you're taking the core, we do offer these core preps, and you can take an online course. So we offer these online courses as well, take the full course, or if you need, we do have just specifically math available to you. So if you're needing more intense instruction, then this would be the way to go. Okay, we also offer the elementary exams and so on and so forth. So if that's something that you're interested in, this is our website, easy to navigate. If you're looking for a physical book, then we offer those as well. We offer them through Amazon, and that works out really well for you because you get your book in a couple of days. nice hard copy. People love working with the hard copy books, and it's great for everybody if that's what you're looking for. So just a couple of things there on our products, what we offer, and more specifically where we are. Just Google Kathleen Jasper, go kathleenjasper.com, and you'll be able to make it to our page. Okay, let's go ahead and get started with the math tonight. So as always, like I say, when we're practicing for these math exams, you have to understand that you're working on a computer exam. So that means wherever you go to take your exam, you're going to be using a computer. Because you're using a computer, it changes the game as far as what you see on the screen is the problems. What you write on your scratch pad, it's blank. So you can't write underneath the problem. You can't mark up the text. So let's say I wanted to circle that because it's a number and I know it's important. You can't do that on the test that you take. And so what you need to do is you need to start practicing so that you understand what it's going to be like during the administration of the test. And that means to get a blank sheet of paper, and anything you need to write down, you only use that blank sheet of paper. Now, if you printed out the problems that we're doing tonight, if you had that PDF and you printed out the problems, most of you will do all your work underneath the problems like I'm going to show you on the slides tonight, which is great, but I want you to get away from that. I want you to just have the problem in front of you so you're looking at it, and then anything you need to do, you write separately. This gets you used to transferring or transposing what's on the screen to your paper, because with 1,452, sometimes people in a fit of dyslexia, they may do 1425. It happens all the time, and you got to be careful. So that's why this is something that you need to work on as you study. So it's not just specifically learning the math, it's learning these test strategies. And that's very important. And that's what I try to highlight as I go through these sessions and all the time as I'm teaching. So let's just go ahead. Let's knock this one out. It's saying that we have a rectangular field has an area of 1,452 square feet. If the length is 3 times the width, which of the following is the length of the field? Okay, so pretty basic as far as we got a field. It's given us it's given us the square foot, but it's not giving us the exact dimension. So algebra is going to be in play here. A couple of things, and this is how they write these: a rectangular field, rectangle. You have to know the properties of a rectangle. Square feet, that means we're going to have to deal with area, and our lengths are kind of arbitrary lengths, 3 times the width. So what we want to do first, anytime we're dealing with these visual types of problems, I want to go ahead and I want to give you my rectangle. So in this rectangle, we have length and width. And to be honest with you, you can make this length and this width, that's a terrible W, or you can make, sorry about that, you can make this length and this width. It doesn't matter, okay? You just have to know that one dimension is length, one dimension is width. So see how I label this length and width? Well, it says the length is 3 times the width. So if we think about that, length is equal to 3 times the width. See how we have 2 variables. We have W and L. Well, if this is a rectangle and I know that I need to get an area, I know that to find area is base times height, length times width, and so on and so forth. So if I did area, well, let's do this. Let's just put the formula up here. Let's have A is equal to length times width, right? So we have length times width. So if I did length times width equals 452, understand that I cannot solve this because I have 2 different variables. So what needs to happen is I need to be able to get same variables. In order to solve algebra, you have to have the same variable. One equation means you can only have one variable. Two equations, then you're allowed to have two variables, and so on and so forth. But because I made length equal to 3 times width, length is equal to something, see, length, but this is also L. So what we want to do is we want to substitute that value. So L is really equal to 3W. So if I just kind of do this and I put 3W here, all right, let me get rid of this. Now I have, because it's a rectangle, this is W, not that this matters here, but this is W and this is 3W, right? Area is equal to length times width. That's what we got at the top here. So now if I do 3W times W should equal 1,452, okay? Because that's length times width, that's base times height. I'll put it in parentheses here. So, right, 3W times W. Now, what is 3W times W? That's going to equal 3W squared, right? Variable times a variable is that variable squared. And then this equals 1,452 still. So because of that, we've got an exponent. This might get a little tricky. So remember, a lot of times, if you're in depends on the mindset that you're in. If you see this 3W squared, you may be thinking, okay, this is a quadratic. I got that exponent there. Things can get a little tricky here. So what we do is let's just deal with the math. Let's break everything down like we normally would. Since there's a 3 on the outside, right, we've got to get rid of this 3 first. So in order to do that, we divide by 3, canceling the 3, and we end up with W squared is equal to, and you do 1452 divided by 3, and you get 484. Now, how do we get rid of a squared? Well, what's the opposite of squaring something? It would be square root. So we square root both numbers, and we get W is equal to 22. So is 22 the answer? So what happens is we go through all of this, and again, this is a technique that is used when developing these types of problems. This is a multi-step problem. Just the simple fact of getting the dimensions on this rectangle, which are 3W and W, is a problem in and of itself, right? Because it only gave us length and width, but then it said our length is 3 times width. So that was something. Then multiplying it all together, then actually solving for the variable. The variable is 22. But the question asks, okay, so remember the last sentence, it's usually 99% of the time the question they're looking for. We want to know the length of the field. Well, this is W. W means width. So 22 is not going to be our answer, even though 22 is in the answer choices. A lot of the times we go through all this work, we forget what the problem was. We come up with an answer, we look at the answer choices, and if it matches, then we just say, oh, okay, I got it. You pick 22 and you move on. You were kind of right because you had to figure out what width is, but you didn't answer the question. So if I go ahead and make some room here so that we're looking for our length, but we could only solve for the variable L or width. So width equals 22, length equals 3W. So now length is equivalent to 3 times 22, which is 66. And that's our correct answer. And that is C. Okay. You knew, okay, you can just probably do it in your head. And I always write a lot of things down while I'm doing these sessions, just so I can have a little bit of a narrative and that you can see step by step what's going on. Most of you probably would not have done this extra work here because you could just say, okay, I know it's 3 times 22. So I'll just do 3 times 22 in my head. Boom, it's done. Try to, and you know, if you're just starting studying or you're done studying and it's your last couple days, week or whatever, start honing in on these skills as far as time management is concerned. And the time management skills are learning how to use your blank sheet of paper, your scratch paper, and also mental math, and then with the calculator. Always make sure you know which calculator that you're able to use on these tests, and make sure you use it. I mean, you have time to pretty much do everything in the calculator. You don't have time to put everything in the calculator, and whatever you get in the calculator, write it down, or vice versa. Okay, so really getting those skills down is going to help you tremendously. All right, next problem. We have 32 students in the 10th grade class. There are 15 of those students on the basketball team and 23 of those students in the drama class. Which diagram correctly shows the number of students on the basketball team, in the drama class, and in both of these activities? Okay, so these are always interesting, and people get confused with these. Okay, so showing that we have 32 students total, there are only two possibilities. They can go basketball and drama. So they have 15 in basketball and 23 in drama. Well, if I just do a quick math, 15 plus 23, I'm going to get 38. So now, how does this make sense that I have 32 students, right? That says 32. But when I add these up, I get 38. How can I have more students than I already have? And that's because there are students that are playing both. Okay, it says there are 15 students on the basketball team, 23 students in the drama class. So just because it says that they're in those classes, it doesn't necessarily mean that they can't play both things. Okay, does that make sense? It didn't say it's exclusive. 15 students are only in basketball and 23 are only in drama. Okay, so you see how that is. I can see how it can be confusing, but it's just how these are worded. So if we look, okay, we see that as you look at the diagrams, 15 and 23 in each class. So I know that A is right? Because I got 15 and I got 23 here. I got 15 and 23 here. C is right. B, 9 and 17. How can I have 9 in basketball when it told me that there are 15 in basketball, right? That doesn't make sense. So B is out. And then 11 and 19, again, not the same numbers. D is out. So we have to figure out what's the deal with this middle number. This middle number is the overlap, right? The students that are in both of these classes. So the way you find that out is you add up what they give us, in this case, the 15 and 23, and then you subtract from the number of total students. So I would do 38 minus 32 to get 6. 6 is going to be our magic number. In this case, it's going to be A right here. So A is the answer. That's going to be our magic number of students that are in both classes. Now, you can't tell me which students, are in, which students they are, and obviously they don't, but that's how we get these extra numbers. So it's, if we were to add all these up in the Venn diagram, we got 15, 23, and then 6, that gives us, what does that give us? 42. So then when you got 42, you're thinking, oh, how many? But just understand, it's not taking extra people. It's just where they are as far as just basketball, just drama, and then in both. Okay, so hopefully that makes sense to everyone. Okay, next one. All right, problem 3. What is the value of the expression shown below? So this gets us back to and we haven't done this in a while, but our order of operations. And order of operations is very important on these tests because they really hammer it home in multiple questions. All right. Order of operations is found, everywhere. So a lot of people do this. A lot of people write out our order of operations, okay, with PEMDAS. We're all familiar with PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. It's good. It's what most people do, but I do it a little differently, and there's a reason for it. Is I go ahead and I go down. It's like tiers, right? We have P for parentheses, then we go E for exponents, then I go M and D. That's another level. And then addition, subtraction is the final level, right? So for parentheses, we start here. If we start with parentheses, we get everything done. Then we move to the next level. Then we move to the next level here. Then we move to the next level here. There is something very important at this level here, okay? And it's the one that confuses most people, or is the reason why most people get these wrong. You'll see this, I mean, if you're on Facebook or really anything, you always see these problems pop up where it says 90% of the population gets this problem wrong. And then they show you a problem kind of like what I have up here now. And then everybody comments like, and they all, half the answers are incorrect. What happens at this level is it must go from left to right, okay? Which means you do it like you would read words on the page, starting from the left and moving to the right, which is why when you write it like this, when you do PEMDAS like this, some people will always do multiplication before they do division, no matter what, because they see it as PEMDAS moving this way. That's why when I do it like this, I set it up as levels. That way, in order to get to one, you got to go down to the other. And then M and D, they're on the same level. So if they're on the same level, then you should try and hopefully remember left to right, okay? You don't always do multiplication before division. That is a misnomer. Okay, so then let's go ahead. If we're doing this problem, remember, I'm working on scratch piece of paper. I see it on the screen. I first thing, rewrite it. So 12 plus 96 dividing by 3 times 2 to the third power. First thing we got to do is our exponents. There are no parentheses. So I'm going to do 2 to the third power, which is just saying 2 times 2 times 2, which equals 8. So now I have 12 plus 96 dividing by 3 times 8. I see that I have division and multiplication. I see division is first. Some people will do multiplication first. Some people will do 3 times 8. 3 times 8 is 24. Then they'll do division, 96 divided by 3 or 24. That's incorrect. The correct way to do it is to move from your left to right, which means we're going to have 12 plus 96 divided by 3. 96 divided by 3. That gives us 32, and then times 8. Next step, do the multiplication. I get 12 plus 32 times 8 is 256. And then finally, just add my 12 and I get 268. Answer C. Okay, so make sure that, and this is the big part of this problem right here, division is going before multiplication on this problem because it comes before multiplication in this problem. Reading from left to right, okay, whatever it is, as long as we're on the same level, right? Because we went from exponents, got that done, first step. Second step, recognize we have division and multiplication. Doesn't matter in which order they are in the problem, we do them from left to right. And once you get that down and once you understand that, because more often than not, whenever you get a problem like this that deals with order of operations, they usually switch it up so division is before multiplication because they know you're thinking PEMDAS in your head, parentheses, exponents, multiplication before division. That's where the mistakes get made. Okay. Moving on. All right, a little bit of radicals. So a quick radical lesson. So these are radicals, is square roots. So it says which number is equivalent to 5 square roots of 8 times 3 square roots of 4. So what we want to do here is just kind of go over what it's like to multiply radicals. So again, rewriting it so that I can work it out on my paper, because I can't work underneath here, do anything to these numbers. So times 3 square roots of 4. I'm going to do this 2 ways. I'll do it this way first. It's the longer way, and then I'll show you how to shorten it up. But in order to multiply radicals, it's not the same as if we're doing like x squared times x to the 3, right? In order for me to do this, I got to have the same base. Well, this is dealing with these radicals. And if you notice, my radicals are radical 8 and radical 4. This does not come into play if we are multiplying, okay? So what we do first is we multiply the outside numbers. So outside goes with outside. 5 times 3 is 15. And then we go inside. They're under a square root, but it's 8 times 4, and that's going to give me 32. So my answer is 15 square roots of 32. Looking at the answer choice, I don't see any 15 square root 32. I see all these radicals with a 2 or a 3. So that means I need to simplify my radical. So here we go with simplifying radicals. It's fairly easy. And if you ever see it on your test, they're not going to give you any large numbers to simplify. The goal is to just understand, can you simplify radicals? Radicals get simplified by finding perfect squares. So what are our perfect squares? If you don't know, or if you can't remember them, just do this. Write out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have that scratch paper. That's what this is for. The 1 is really irrelevant, but it's just easier to say write 1 through 10, and then just square every number. 1 times 1 is 1. 2 times 2 is 4. 9, 16, 25, 36, 49, 64, 81, 100. What this is our perfect squares. 4, 9, 16, 25, 36, 49, 64, 81, 100. If we were to square root these numbers, you're always going to get, so like if this were x, this is the square root of x. Does that make sense? So if I took this square root, I get 2. The perfect root of 9 is 3. 16 is 4. Okay, get the idea. When you have a number under a radical, in this case 32, the way to simplify it is to find out what the highest perfect square root or perfect root is. And by perfect root, I mean these x values. So you know that 36 is too large, right? 36 is too large for 32. You can't do 32 divided by 36, but we can do 32 divided. So that's where we start. We always start at the highest possible point we can and work our way down. So 32 divided by 36, not going to get us anything. 32 divided by 25, not going to get us anything because it's a 5, should end in 5 and 0. 32 divided by 16. Okay, looks like 16 will work. So if I do 32 divided by 16, so 32 divided by 16, I get 2, which means 2 times 16 equals 32, right? Makes sense? So I'm going to go ahead and erase this. All right, but that's if you ever forget what your perfect squares are, just go ahead and run right through 10 and then square them all up. So because I know that 16 and 2 work as my factors, one being a perfect square factor, this now becomes 15 and the square root of 16. I always put the perfect square factor first, and the square root of 2. Okay, hopefully that makes sense, because 32 gets broken up into 16 and 2. Why didn't I do 8 and 3? Because none of these are perfect squares. That's what this is. That's why this 16 is so important, okay? Because my next step is to then simplify. I know that the square root of 16 is 4. So that comes out. So it's now 15 times 4 times square root of 2. 15 times 4 gives me 60. Square root of 2 cannot be simplified any further. And therefore, B is the correct answer there. So that is simplifying roots. That's all it is. Maybe you'll get 1 on your test just because it is a standard that is assessed, radicals, dealing with exponents, vice versa. It's all intertwined together. But simplifying a radical, even if it's a simple number, it may not be 32, you may get 8. 8's a good one. So just having the understanding of doing that, find the largest possible perfect square factor. And in this case for 32, 16 was my largest square factor. All right. If you recognize, okay, the more practice you do on these, the more you'll recognize, certain roots and how they break down. So with this one right here, I've got 5 square roots of 8 times 3 square roots of 4. Well, I know that my root for 8 is going to be 5 and then 4 times square roots of 2, right? Because 4 times 2 is 8. And then with my 3, I know that the square root of 4 is already a perfect square. Let's just multiply it by 2. So then let's just clean this up a little more. I've got, what do I got here? I got 5 times 2 times square root of 2 times, well, I can just do it. And again, whatever you can do in your head, do in your head. I'm writing this down so that you can see where my thought process is coming from. 3 times 2 is 6. Now I've got 5 times 2, which is 10, right? 5 times 2 is 10. And then my last number is way over here times 6. So 10 times 6 gives me 60. My square root of 2 is still here. I can't do anything with it. Again, I get the same exact answer as I'm supposed to, 60 square roots of 2. Okay. So that is dealing with radicals. All right, next one. So I always like to try and pull a lot of these problems for the simple fact that this is what happens when they give you these with graphs or charts. It fills up the screen. When you click the button to go next on your test and the whole screen fills up with a math problem, it's overwhelming. It's like, whoa, that's a lot. But I'm here to let you know all of these problems are designed to be solved within the time frame that they're given. Again, whatever test you're taking, make sure that you research how much time you're given per problem. It will give you, and that's a math problem itself, it will give you the test question amount, and then underneath it, it will give you the time. Take the time, divide it by the questions, and that's how much time you will get per question, okay? So in this one, we've got information about the cost of 3 catering companies are shown in the table. We have Acme, Best, Creative. We have all the different situations. And the question says, Gavin can spend no more than $300 on catering for an event. What is the greatest number of people that Gavin can have at his event without spending more than $300 on catering? Sometimes the questions can be confusing. What do you mean the greatest number of people? I've got 3 companies here. How are we supposed to solve this? So what it means is, what is the best value for my money as far as how many people I can get? So what we do, we just go right on down the line. So we're given this 300, so $300, okay, no more than $300. So 300 is our limit. So for this first company here, and again, something like this, there's really no shortcut other than jump right in and figure it out. So this first one, we'll say we got $6 per person plus a 100 flat fee. So if we have to start with $300, we already take away $100, leaving us with $200. And again, all this can be done on your calculator. So really, if this were me, I would do it on the calculator. I would just stare at the screen and put the numbers in the calculator. So in this case, I would do 300, right? Just following along what I wrote down, 300 minus 100 equals, okay? Once I hit equals, I've got the number in the calculator. It's 200. The number's still there, I can continue. So if I were still writing this, now it's $6 per person for this one. So we need to divide by 6 to see how many people we can have for this one. So the calculator already's got the answer in it. Divide 6 equals, and it's showing us that we can do 33.3 people. Here's the problem with this. Be careful. It's 33.3 people because people can't be a fraction, right? 0.3 of a person. Are you supposed to round up or are you supposed to round down? Okay. And in this case, you can't buy, right? In this scenario, I can't have 33 people and then a chair with a third of a person. I can't invite 33 and a third person, can I? So really, this equals 33. Okay, does that make sense? So this first company, I got 33. Let's move on to the next one. The next one, again, I'm using my $300. And this time I take away the $40 flat fee and I get the 260, but then I need to divide by $8 per person this time. Okay, the price went up per person. So when I do that, 260 divided by 8, I get 32. Clean this up a little bit. 32.5. Again, if I'm dealing with a fraction of a person, what is this going to be? This is 0.5. This one messes with your head because anything that's 0.5 and above, you're supposed to round up, right? So if I rounded this up to 33, that would be wrong because I really could not afford 33 people with this company. So again, rounding down, just like in the first one, we will be able to do 32. Well, since it's asking us for what is the greatest number, I already know that this company is out, or at least this number is out because 32 is less than 33. So 33 is still my high number. And then finally for the last one, starting with my $300, there's no fee involved with it, but it is $10 per person. So 300 divided by 10 gives me 30. And that is not the largest number here. So that's out, 33 becomes the largest amount of people, my best value for what I can get for the money, okay? Because it said, what is the greatest number without spending more than $300? And if I spend $300, I can get 33 people using the first company, okay? So number 5 is C. Okay. A little bit of number lines. I like the number lines because when you get a number line on these types of tests, it's not going to be so straightforward. So what do I mean by that? It says an engine is operating at 25% of its power. Which number line shows a point that represents 25%? Well, these all say 0 through 1, right? I got 0 through 1. So that means 25% is, well, we know that it's 0.25. Well, that doesn't help me out here because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different lines. So that doesn't help me out there. Nothing's labeled. This can be interesting. So we know that it's, 25% is 0.25. It's 1 over 4, right? 1 out of 4. So what we have to do here is we have to find out where that 1 out of 4 is. So it's basically saying, if these are all on, see how these are all on specific lines? That means that we're going to have, we'll have an even number because it'll be in some equivalent or some multiple of 4. So 1/4 is the same as 2/8, right? It's also the same as 3 yeah, just keep doubling it, right? 3 12s and so on. So I'm looking for some type of even number that'll break up into 4s. So if I look at this, understand that this is, and I know I'm writing one, but I'm just counting the numbers, the number of lines. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So let me do this so you can kind of see it here. If there are 10 individual lines, right, or 10 spaces, in order for it to be 1/4, right? So with 10, how can 10 equal 1/4? It really can't, because it's not a multiple. All right. So this isn't going to work out well, because this is 2 out of 10. Does that make sense? It's on the second one. There are 10 total. 2 out of 10 breaks down to 1/5, which is 0.20. So that does not work. So that's gone. This one is 1, 2, 3, 4, 5, 6, 7, 8. This one is on the second one again. This one is 2 out of 8. Break down 1/4, 0.25. That's our winner. This is the answer. Okay. The other ones, just so you get the practice: 1, 2, 3, 4, 5. Again, this is on the second one. 2 out of 5 is equivalent to 0.40. Again, not what we're looking for. And then the last one, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is on the fourth one. It's 4 out of 12, which is close, but that's gonna break down into 1/3, which is 0.33. Again, not gonna work. That's how we do it. We got to figure out how many spaces run in between each of those. Even though this is 1, it's the amount of each space that's in between. Okay. So just a quick problem on this. Again, knowing your axes on a graph are similar to this as well, because just because it's 0 through 1, you can see these are 4 different graphs with 4 different intervals in between each one, representing different measurements. Okay. All right, next problem here. Table shows the approximate median annual salaries associated with 2 levels of education. Okay, there's our chart: master's, bachelor's, level, median. Okay. Based on the data in the table, how much more money would a person with a master's degree earn than a person with a bachelor's degree over a 35-year career? Oh boy. So if we are making this much money and they want us to see what is the difference between a 35-year career, what should we do? What is that? What makes sense in your mind to go ahead and solve this? So what we would do is multiply this by 35, multiply this by 35, and then subtract or get the difference between the two. What happens is you get really big numbers. So let's just think logically here. If I know these are my salaries, let's take the 69,100 69,100 subtract 57,600, we will get the difference in our salaries. Okay, makes sense. Pretty straightforward. 69,100 minus 57,600, and we get $11,500. Why is it easier this way? Well, if I know that the difference between the two is $11,500, it's always going to be the difference between the two, no matter how long we go, right? It's based on this problem in this scenario, it's never going to change. So I can take these manageable numbers, get this 11,500, and then if it's 35 years of time that we need to go, well, just multiply it by 35 years. And again, all this is done in your calculator. There's no need to really write any of this stuff down. I'm writing it down so it's like a blueprint for you, but really get used to, even if you're not used to using your calculator, get used to using your calculator because it's going to save you so much time and it's going to help you get the right answer. So 11,500 times 35 leaves us with, your answer is already in the calculator, but we have 402,500, and that's the answer there. Okay, pretty easy, pretty straightforward. A lot of people may not do it that way. This is why I showed it to you first, because I'll show you if we did it the other way. If I have, okay, here's my 69,100 for my master's salary. I want to multiply it by 35. I'm going to end up with this really large number, 241,8500. And then if I do the 57,600 and I do that by 35, then I'm going to get another large number, 201,6000. We need to take the difference of that. The difference is going, and again, you're punching all these numbers in your calculator. You can't just do this one all in the calculator in one fell stroke. You can do the first way, just not the second way. Will you get the answer right here? Of course you will. It's just a longer way of doing it. And that yields the 402,500. Okay. Make sure you're comfortable with your calculator. All right. Yesterday, 170 guests at a hotel called for room service, and 255 guests did not call for room service. What percentage of the guests at this hotel called for room service yesterday? I picked this problem because I could see where people would get maybe frustrated or, get hung up on one little thing when it's just a simple like these two sentences can be very confusing for some people, because what they're giving us is 170 and 255. And we know when we deal with percentage, we just take what we have over, whatever it is that we want, in this case, room service, over the total guests. And if you look at it quickly, you might just do this. You might just go, oh, well, 170 wanted room service. Excuse me, at a 255. If we're to do 170 divided by 255, I get 66.6. We'll go 7 there. There's nothing that's close to 66.6 or 67%, because I got 60, 15, 40, and 85. Well, now we're stuck. We're struggling because we don't understand where we are and we might just guess. So what we have to see is how they wrote down this problem. It's only giving us the 170 that called and the 255 that didn't. So that means 170 out of 170 plus 255. That's important. That bottom number is important because that represents the entire hotel, because it's giving me those that didn't and those that did. So that comes out to 170 over 425, which gives us 0.4 or 40%. 40% is the correct answer, C. Okay. I did that because these are those little problems where you see large word problems that have those graphs on them, overwhelming problems, and then you get to something like this and you're like, oh, it's almost too easy, I can just blow right through this one, and you get stuck and you start staring at it, and you might be here for a minute, 2 minutes, just killing time. You got to stay focused and you got to catch these types of problems, understand these types of problems so that you don't make any mistakes. Okay. Next problem. Chose this problem specifically for the stem and leaf plot. The stem and leaf plot shows the percentage of questions on a Spanish test that were answered correctly by each student in a class. The stem and leaf plot is there. Which statement is true? Okay. These problems, again, it's hard to really look at the answer choices and eliminate anything right away, because really the problem is in the answer choices. So a stem and leaf plot, let's just real quick go over what a stem and leaf plot is. It's on the left is the stem, and we've got these numbers here, 7, 8, 9, 10. The leaves are on the right side, and you'll see there's multiple numbers and also lots of the same numbers repeating themselves. How can we have these repeat themselves? That doesn't make sense, okay? Until we understand, you take the stem plus the leaf and you get the actual value. So a 7 and a 0 equals 70. A 7 and a 5 equals 75. When they're multiple, it just means it happens multiple times, right? There are 1, 2, 3, 4. There are 5 75s, okay? Let me clean this up. This right here says there are 5 75s. So what that means, 3 70s. The next one, 3 80s, 3 85s, and then so on and so forth. So you have to understand how to read these first, and then you'll be able to understand the problems and you get them done quicker. So let's blow through the answer choices. A says 9 students answered 55% of the questions correctly. As I look, I see this 55%. Where do I see 55%? Well, there is no stem that has a 5 in it, because if there was, it would look like this. This is students answering 55%. It would have, and I know it goes in numerical order, but just because I have room, I'll put the 5 here, and then I'll put the 5 here. That's one person answering 55%, right? Because a 5 and a 5. 9 students would look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. That is 9 students answering 55% of the questions correctly. Okay. Obviously, that's not there because I put that there, but that's what that is. That is incorrect. That does not exist. A is not the correct answer. Moving on. Half the students answered 70% or 75% of the questions correctly. So as we go through this, let's count how many students we had, because it didn't give us in the question. So real quick, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, right? There are 19, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's 19 students, okay? 19. It says half the students answered 70 or 75%. Well, if this is 19 and I divide it by 2, what do I get? I get 9.5. I can't have 0.5 because it says half. It didn't say almost half or kind of half, it said half. And if I have an odd number of students, I can't have half. So without doing anything or out counting anything else, B cannot be the answer. All right. If you didn't catch that, then what you would have done is you would have counted, you would have done this. You would have thought, okay, there's 19. As I go through, I got 70 or 75. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. And then when I count 8 out of 19, and that obviously not going to give us 0.42. That's not half, right? Half would be 1/2, 0.5. So there we go. That's out of the answer. Our next is C. It says 8 students answered more than 80% of the questions correctly. Okay, keyword, more than. In this scenario, can I use 80%? No, you can't, because 80% is equal to 80%. I need more than. So 8 students are more than. So here we go. I start at 85. So that's 1, 2, 3, 4, 5, 6, 7, because obviously anything in the 90s will work. And then anything that's 100 will work. And that's number 8. And so yes, 8 students did answer more than 80% of them correctly. C is the correct answer. We can go through again the last one. And it says 10 students answered 100% of the questions correctly. And that's not true. 10 is here, right? 10 is the stem. That means this is 10 and the 0. It gives us 100. What does 10 100s look like. Again, if you're new to stem and leaf plots, this would be 10 100s, 2, 3, 4, 5, 6, 7, 8, 9, 10. You'd see 10 zeros after it, okay? So D is out, C is the correct answer. Once you understand these and know that you're gonna have to go through all the answer choices to solve this, you'll do it much quicker. I know you will, I have confidence that you will. It's just the first time is always the slowest, but when you get questions like this, where you have to use the answer choices to answer it, obviously you got to answer it, but where really the question is within the answer choices, you got to work through all of them. And then if you're confident enough, when I found C, I knew C was right. I just knew it was, there's no other way it couldn't be. I would stop and move on. I wouldn't even bother with D, but some people get paranoid and they're just not sure of themselves, and that's okay. You can work it out, but just manage your time. All right, last one. I've got a rectangular garden that is 3 yards wide and 4.5 yards long to be covered with soil. If the bag of soil covers an area of 20 square feet, which of the following is closest to the number of bags of soil needed to cover the garden? Okay, pretty straightforward. What we need to look for and what you need to notice is this. I'm dealing in yards, and my bag covers square feet. So what am I to do? And what you should do is you should always convert, obviously, but what should you convert to? Because as you notice here, there are no units because the units are in bags, right? It says how many bags of soil. So depending on what you want, you can convert any way. And what I always encourage is to go from big to small, big unit to small unit. What I have here is I have yards, big unit, feet, small unit. You also would like, or always want to convert before you do anything else. So what I mean is, let's do this. I want to go from big unit to small unit. Whenever you go from big to small, you always multiply. Okay. Big unit being yards, small unit being feet. What I have here is I have 3 yards. So my first one is 3 yards, and I'm going to multiply it by, well, what do you multiply it by? That's the other thing that's important. You multiply whatever the magic number is. So you look on your reference sheet and you see that 1 yard is equal to 3 feet. Or you may see 3 feet is equal to 1 yard. It doesn't matter. I know that if I am doing big to small yards, yards are multiplying by 3 feet. So it's by 3. So 3 times 3 gives me 9. And then my 4.5 times 3 is going to give me 13.5. Right, 4.5. Okay, so these are my new dimensions. And it's important that you do these. These are now feet, feet, feet. If you did the opposite, so real quick, small to big, you divide, right? I would have feet, and then I would divide by 3, right? 3 is the magic number because 3 feet, 1 yard, 1 foot, or sorry, 3 feet, 1 yard, 1 yard, 3 feet. 3 is your number. So small to big, big to small. Okay, we have our new dimensions. So that's the important part. Understand that you have to convert your dimensions. Next, we need to go ahead and let's build our garden just to make sense of everything. I'm just gonna erase this, but you know what we have. I'll rewrite it again. We've got our rectangular garden, just like this. We know that it is now 13.5 feet by 9 feet. Okay. So we find our area. The reason why you want to do this, sorry, it just, draw things quick and it looks a little sloppy, so got to pay more attention to that. 13.5 feet, 9 feet. I don't know if that's much better, but you get the idea. I need to find out what is the area of this. So in previous problem, area is equal to length times width. So our area is equivalent to 13.5 times 9. And when we do that, nope, 13.5 times 9 equal. Okay, we end up with 121.5 square feet. The reason why we convert our dimensions before we do the area, so like some people will just say, well, why can't we just do the 3 times 4.5, get our number, and then go ahead and convert that? Well, it doesn't work out that way because we are now in 2 dimensions, linear. So if I find the length of something, yeah, I could do 3 plus 4.5 and then convert it and I'd be fine. But because I'm now doing 3 times 4.5, I've taken it to another dimension, right? So 2 dimensions, which means you got to square it. That's why you get square feet. It's not worth getting into. Just know, always convert your dimensions before doing any area or volume. So I'm left with 121.5 feet squared. So how many of these bags? Each bag is worth 20, right? So I divide by 20, and that's going to give me how many bags I'll need. So when I do 121.5 divided by 20, we get 6.075. Okay. Now I kind of manipulated these numbers on purpose because I wanted to see what people would answer. And when you see this number here, 6.075, this is a minuscule amount, right? That's a small amount because it's 6.0, or if I were to round it, 6.1. It's such a small number. What am I supposed to do? How many bags do I need? Do I need 6 bags or do I need 7 bags? I need to cover the entire garden. If I do what I normally do and I just round, I should go down to 6. So if I were to pick 6 bags, what happens? Did you cover the entire garden? No, you didn't, because you've got this left over. It's just like saying I covered the entire thing except for this little piece right here. So technically, did you cover the whole garden? No, you didn't. Anytime you're dealing with a problem where it asks if you're covering something, in this case, soil in a garden, if you're tiling a floor, if you're carpeting a floor, if you're painting a wall, and they give you certain amounts like 20 square feet per bag, 100 square feet per bucket, all these different things. If you end up in a fraction or a decimal of any kind, always round up to the next whole number, period. In this case, we've got the 6.075 or 6.1. I can't buy 6 bags of mulch. I can't buy 6.1 bags of mulch. I buy the next whole number, that whole number being 7. So 7 is the answer to this problem. Don't make the mistake of rounding down and just saying, oh, well, it's a little amount. Well, if it's your garden or if it's your bathroom tile or paint on the wall and you're paying a contractor or you're paying money to get this done, don't you want it all complete? Or are you just gonna say, you know what? It's only 0.2 of the wall or 0.2 of the garden. I can make it work. No, that's not how it works. So just be careful with these problems. Any fraction of the number, doesn't matter how big or how small, always round up to the next whole number, period. Okay. And that's the reasoning for this problem here, because I know you're going to see problems very similar to it. Okay. As far as how the answer comes out. All right. That takes care of that for this evening. How time flies when you're having fun, especially with math. Last page is always the answer key. And if you have any questions, any problems, or you want to share problems with me to do, on next week's session and on, please contact us, info@Kathleen with a K, Jasper.com, or you can always reach us on the website that I showed you, KathleenJasper.com. And we are happy to go ahead and get you whatever information that you need. I want to do one quick check on Facebook. Hopefully, I didn't see any comments. Okay, I really need more. Okay, this does not ring a bell at all. I really need more practice. Yeah, if you see something that you need more practice on, then Google it, throw it in, shoot me an email, tell me which problem it was, and I can point you in the right direction to get more help for that problem. Practice is everything. The more you see, the more you're able to do, and then get into those rhythms of using your calculator, using your scratch paper, because the biggest hurdle for any of these standardized tests is time. Okay, so understanding your time management and dealing with that is crucial. Okay, so that is it for this evening. I want to thank everybody for joining me, and for everybody else that's watching this and watching our feeds and getting some good stuff out of it. That's what I'm here for. That's what we do. We're here to help you. We're here to help teachers become teachers. And so if you need anything, again, please hit us up: Facebook, Instagram, Twitter, YouTube, all the platforms, KathleenJasper.com. Hope everybody's having a great semester. Believe it or not, Thanksgiving is next week. I don't know if you have the whole week off. I don't know if you have a few days off, but maybe get some rest, get some studying in, get your tests ready to go so that you can get your certifications done before the semester or during the semester breaks, whatever it may be. Don't put off getting your teacher certification. So with that being said, I will be here next Tuesday, as far as I know. So a lot of people won't. You'll be out of town, whatever it may be. Doesn't matter. There'll be another session for you to come back to. But have a great Thanksgiving week if I don't see you, and enjoy it. All right, everybody. Have a great one, and I will see you next Tuesday.